Good day everyone. In part 1, you learnt 16 formulae and some basic sums, right? Now, let me tell you one other concept now, a different concept, right? Now, you know, integral cos x dx is equal to sin x plus c. This is a formula. Now, supposing instead of that x you have cos 3x dx or cos 7x dx like that. That is, there is a coefficient before that x. In such time, what to do? Now, for cos 3x, you have to write sin 3x, okay? Then, that coefficient is 3, you have to divide by the coefficient. In differentiation, you will multiply, here you will divide, plus c, right? Use the same thing here. Integral cos 7x dx is equal to sin 7x. Cos 7x means you write sin 7x. Then by divide by the coefficient plus c. Do you follow? Similarly for anything. Integral sin x is equal to minus cos x plus c. Integral sin 2x is equal to means minus cos 2x by 2 plus c. Okay? So like that for all the things, wherever you get a coefficient, you have to divide it. Now, come to the exponential function. You know integral e power x dx is equal to e power x plus c. If you have integral e power 2x, for e power 2x, you write first e power 2x, divide by the coefficient, then put plus c. Okay? Then e power minus 4x dx, that will be e power minus 4x, write the same thing. Then divide by the coefficient minus 4 plus c. These things are clear to you. Now, let us come to this formula. Integral a power x dx is equal to a power x by log a plus c. Now, first a straight sum let us do. Integral 5 power x dx. In the place of a, you have 5 here, right? Using that formula, you will get 5 power x by log 5 plus c. So, here you have an x in the formula also, you have an x. Now, look at the next one. Integral 5 power 3x dx means, first for that 5 power 3x, you write 5 power 3x by log 5, okay? Then, for that x, the coefficient is 3. So, you have to divide. So, it will come as 3 here, then plus c. So, wherever you get a coefficient like this, you have to divide by the coefficient. Remember, this is one important concept or rule you should remember in integration. Okay? You have the first formula. Integral x power n dx is equal to x power n plus 1 by n plus 1 plus c. I already told you that x, that should be a linear algebraic function, then only you can use that formula. See, supposing you are having integral sin squared x. In that case, you cannot use this formula and write sin cube x by 3, okay? Because sin x is a sine function. It is not a linear algebraic function. So, for trigonometric things, there are some trigonometric formulae which we have to use, and then only we can integrate. So, first I am giving you 4 important formulae you should know to deal with problems of type of sin squared, cos squared, sin cube and cos cube. So, now from the cos 2x formula I am deriving sin squared x is equal to 1 minus cos 2x by 2, and cos squared x is equal to 1 plus cos 2x by 2. These two formulae we derive from cos 2x formula. You have cos 2x is equal to 2 cos squared x minus 1 or 1 minus 2 sin squared x. From that we derive. The third and fourth, I have actually shown the derivation. That is, sin 3x is equal to 3 sin x minus 4 sin cube x. I bring that 4 sin cube x here, that becomes plus. So, 3 sin x minus sin 3x. If I get sin cube x, I can write that is 1 by 4 into 3 sin x minus sin 3x. Okay? Cos 3x, what is the formula? 4 cos cube x minus 3 cos x. Keep the 4 cos cube x here itself. Bring the minus 3 cos x here. That becomes plus 3 cos x. So cos cube x will be 1 by 4 into cos 3x plus 3 cos x. In all these 4 cases, you can notice one similarity. That is, here you have powers, in the trigonometric function you have 2 here and you have 3 in these 2. Now, we are having a formula where we get them in terms of multiple angles like 2x, 2x and here 3x and x like that, because we can easily integrate any trigonometric function if it is in terms of multiple angles. So, these 4 formulae also you have to write down in your notebook, and there are some more. So, the trigonometric formulae which will help you to do the integration. So, definitely these are very important. Please write these 4 formulae in your formula notebook. Now, let us take one sum. That is, generally we say I is equal to any integration sum. In the part 1 we had very simple sum, so I didn't use that I. Generally, in differentiation we write y is equal to. In integration you have to write I is equal to, okay. So, I is equal to integral sine squared 3x plus 2 dx, okay. So, now this is of the form of some sine squared x. In the place of x, now you have 3x plus 2. So, using the first formula, I can write this as 1 minus cos 2 into, in the place of x you write 3x plus 2 whole by 2, then dx. Do you follow the first step I have done? You know sine squared x is equal to 1 minus cos 2x by 2. So, here in the place of x I have 3x plus 2. So, I am writing it as 1 minus cos 2 into 3x plus 2 by 2 dx, right? Now, this 2 in the denominator I am taking outside the integral as 1 by 2. Then I write this 1 as it is. Here I expand the bracket, so I get 6x plus 4 dx. Okay? Now, you are just having 2 terms which you can integrate easily. So, here this half you write as it is, put a bracket. For this 1, you know it will be x, is it? 1x. You remember any constant I told you, there will be 1x. Then, for this term, you know integral cos x dx is sin x, isn't it? So, there is already a minus sign, put that first. Then, sin, in the place of x you get 6x plus 4 by, what is the coefficient of x there? 6. So, write by 6, close the bracket, plus 6. Do you understand? So, what did we do first? Sine squared x. We used the formula 1 minus cos 2x by 2. Then we took that 2 in the denominator as 1 by 2 outside the integral. Then we integrated this 1, that is x. 1 means 1x. 2 means 2x. Cos of something is sine of that. Then divide by the coefficient. Here, don't put the by for this one. It is for the whole thing. Okay? Remember that also. So, do you understand this sum? Then, let us do one sum which involves some cubic function. Okay? Now, look at this sum. I is equal to integral cos cube 3x minus 7 dx. So, now, it is something to do with the fourth formula, isn't it? For cos cube x, you know, it is 1 by 4 into cos 3x plus 3 cos x. So, this is the formula I am going to make use of now. If you are not able to by heart these two, you have to derive from. So, at least you know the basic one, that is sin 3x and cos 3x. Then, of course, only 2 steps you can quickly derive and then you can make use. These two are very easy for you to by heart. Okay. So, now I will write here this cos cube. In the place of x, I have 3x minus 7. So, first I will write 1 by 4. Then I will write the bracket. I will put a bracket. So that is integral sign. Then I will write now integral cos 3x, that is 3 into 3x minus 7, okay, plus 3 cos 3x minus 7, put a bracket and dx. We have made use of this formula, right? 1 by 4 out, cos 3, x is 3x minus 7 plus 3 cos 3x minus 7 dx. Now let us expand the bracket and write it properly. So this is cos 9x minus 21 plus 3 cos 3x minus 7 dx, right? You know, integral cos x dx is equal to sin x plus c. So here, this 1 by 4 you write as it is. You will get sin 9x minus 21 by 9, because the coefficient of x is 9, right? Then plus 3. For this again you will get sin 3x minus 7. Here the coefficient is 3. So by 3 plus c. This 3 goes. And here you can write this as 1 by 36 sin 9x minus 21. If you want, you can take the 3 within the sign, you can write, or you write it like this, plus sin 3x minus 7 plus c. So do you understand how to deal with sums involving sin squared, cos squared, sin cube and cos cube? Is that clear? Because let us go a bit slow so that I want you to understand each concept clearly. So first I taught you what to do if there is a coefficient before x, we have to divide. Then for sums of cos squared, sin cube, cos cube, I give you the formula, and 2 sums I have worked out. So you can work out similar sums from your textbook. Now let me teach you one more concept today, right? Now look at this sum. I is equal to integral sin 2x cos 3x dx. Actually you are having a product of 2 trigonometric functions. Both may be sine, both may be cos, or one sine and one cos. Whatever, if it is a product form, we are going to use trigonometric formula and convert it as a sum or difference of 2 trigonometric functions. Then we can integrate them easily. For that, you need to know these 3 formulae. Already I gave you 4 formulae, which are trigonometric formulae, which you have to use in integration. Now 3 more. Now, if 2 sin A cos B, that is if it is of a product 1 sin and 1 cos, 2 sin A cos B is sin of A plus B plus sin of A minus B. You know the basic formula, sin of A plus B is sin A cos B plus cos A sin B. Sin of A minus B is sin A cos B minus cos A sin B. So that cos A sin B will get cut and you will get 2 sin A cos B, right? Similarly, 2 cos A cos B, both are cos. In that case, you will get cos of A plus B plus cos of A minus B. Then, if both are sine, that is 2 sin A sin B, it will be cos of A minus B minus cos of A plus B. Here, I have not given you 2 cos A sin B because there is no need. The sine, whatever is there, you keep it as A. The cos, you keep it as B. So, I am just reducing one by hotting one formula, right? Okay. So, now these 3 you copy down in the same notebook because these are all the trigonometric formulae we are using, right? So, now let us take this sum. You have a product of 2 things, but I don't have a 2. That doesn't matter. I can put a 1 by 2 in the formula. So, now this is like sin A cos B. So, see the formula 5. So, now because the 2 is there, I will compensate. I will put a half here, right? Then within integral, it will be sin of A plus B. See, this is A and this is B. So, I will get A plus B means I will get 7x, right? Plus sin of A minus B. So a minus b will be 2x minus 3x. So that will be minus x dx. You know, sine of minus theta is minus sine theta because in the fourth quadrant sine theta is negative. See, actually you don't have trigonometry this year, but all the trigonometric concepts which you studied you are using in differentiation, and now you are learning them in integration. So you should remember all the bases. So here I can write this is half integral sine 7x minus sin x dx. Now it is easy for me. You know, integral sin x dx is equal to minus cos x plus c. This is the basic formula, right? So here you have sin 7x. So you will get half into, put a bracket, minus cos 7x divided by the coefficient 7. Okay? Then here there is a minus. In the formula you are going to get another minus, so that will become plus. Now you will get cos x, then plus c. That's all. The half you can keep here itself, and this is the answer for this sum. So actually if you look at these sums, the sums are easy only. But you should know the trigonometric formulae which you have to use, and then only it will be, you will be able to actually integrate, and the integration part is simple only. So do you understand this sum? So when it is a product of either one sine and one cos, or both cosines or both sine, use these three formulae. You can get as a sum or difference, and then use the basic formula, and then you can integrate. Okay, is it clear? Now see this sum. I is equal to integral cos x, cos 2x, cos 3x dx. You are having a product of three cosine functions. Now how are we going to deal with it? You know, only 2 cos a cos b is equal to cos of a plus b plus cos of a minus b. So what we will do is, we can take any two terms together. So now I am going to consider the first two terms alone. For that I am going to apply the formula. So I will write 1 by 2 out. You remember, because the formula is for 2 cos a cos b, I am writing 1 by 2 out. For these two, the x is a and this 2x is b, right? So using that formula I will get cos a plus b, so that will be 3x, plus cos a minus b, that will be cos of minus x. Then write the third term as it is. Okay? This is the first step. Now, you know, cos of minus theta is cos theta. In the fourth quadrant, cos theta is positive, right? So now I will write this as half integral cos 3x plus cos x, then outside another cos 3x dx. Let us expand the bracket. So I will get half integral cos x cos 3x, cos x cos 3x. Okay? Sorry, this is cos 3x, isn't it? This is cos 3x and that is cos x. So I will get here cos squared 3x. Sorry, I will get here cos 3x into cos 3x. So I will get cos squared 3x. Then plus cos x cos 3x dx. Now, still it is not in the proper format. I am having a square here, I am having a product here. So, once again I have to use some formula. So, you know, for cos squared x, we have done in the last one, I gave you 4 formulae, no? So, that will be 1 plus cos 2x by 2. So, now I can write this as half integral. This cos squared 3x will become 1 plus, okay, cos 2x. In the place of x you have 3x. So 2 into 3x, that will be 6x by 2. Do you understand? Cos squared 3x is 1 plus cos 6x. How you got 6x? In the place of x you have 3x. 2 into 3x is 6x by 2. Then coming to this part, again, here I have to use one formula. So let me put another bracket. Here I will take 1/2, right? Then this is like cos A, cos B. This is A and this is B. So cos of A plus B, that will be cos 4x, plus cos of A minus B, x minus 3x, that will be cos of minus 2x. You know cos of minus theta is cos theta. So I will straight away write plus cos 2x. Then the total bracket, then dx. Let us properly arrange this before integrating. I have for these two terms 1/2 for these two terms. So that 1/2 I can take out. So I will get 1/4 out. Do you follow? Then integral, I will write 1 plus cos 6x. Okay? Then I am having cos 4x. Then I am having cos 2x. Then dx. Right? Now everything is in order. We can easily integrate. So now 1/4, put a bracket. For 1 you know it is 1x, right? Then cos 6x, integral cos 6 dx is sin x plus c. So here for cos 6x you will get sin 6x by 6. For cos 4x you will get sin 4x by 4. Here you will get sin 2x by 2. Then plus c. If you want, you can leave it like that. If you want to take LCM, you can simplify. But this is enough. So now let me explain it once again. When you have product of three trigonometric functions, you can take any two. That won't change your answer, okay? So I have taken the first two. I am using the formula that cos A, cos B. So that 1/2 I am writing and I am using the formula. The third one I am writing as it is. Then that bracket I am going to expand. That is first this cos of minus x I wrote as cos x. Then I am expanding this bracket. So I get some cos squared term and again a product. So for the cos squared I use the previous formula, that is 1 plus cos 2x by 2. So I got 1 plus cos 6x by 2. Here again I use the formula. Then on 1/2 I took common and I got the terms. Then I integrated. So are you clear with the sums I explained in this part 2 in the second video? So here mainly you learned how to deal with the coefficients when x has, you have to divide, that is one thing. Then how to integrate sine squared, how to integrate cos squared, sine cube, cos cube. Then a product of two functions and a product of three functions, trigonometric functions. Either sine or cos, you have the formula, so you can do it. So you can try similar sums in your exercise 7.3. But of course, we have not yet completed that. That we will see in the next video. Because I don't want to thrust too many things in one video. So whatever I teach in one part, if you are clear, then it will be easy for you to follow the next one. So let me do some more in the next video. Thanks for watching the video. I have already told you, if you like it, please share it with your friends. Okay.